All right, geometry, circles and polygons 1. This is Unit 4, Lesson 8, last lesson of this chapter. By the end of the lesson, we're going to employ conjectures on the rhombus, rectangle, and square for their diagonals to find angle and segment measurements, as well as calculate angle measurements using the rhombus angles conjecture. Just a reminder, in this rectangular space down here, parallelograms are quadrilaterals whose opposite sides are parallel. We've talked about that on a number of occasions. Rhombuses, rectangles, and squares are all specific types of parallelograms. Therefore, any property that's true for parallelograms also applies to these other shapes. Let's go ahead and get started with our notes. The rhombus is an example of an equilateral parallelogram, meaning its sides all have the same measure. Properties of a rhombus. The diagonals of a rhombus are perpendicular bisectors of each other. That means is that this diagonal cuts the other diagonal in half and forms a right angle. Likewise the other way around. So the two segments on each of the diagonals are congruent and there's a right angle formed. Okay, likewise, the diagonals of a rhombus bisect the angles of a rhombus. Okay, you can see the symmetry here. If I were to fold the rhombus along this diagonal, these two angles would form perfectly, line up perfectly with those, and these two angles would also align properly. Likewise, if I were to fold horizontally across this vertical diagonal here, the two sides of the rhombus would match up perfectly. To bisect means to cut in half. So this angle A, which would consist of the following, is cut into two equal angle measures. You can see by those blue angles. All right, let's look at some more. Specifically, let's look at the rectangle. The rectangle is an equiangular parallelogram. Therefore, all angles are equal in the rectangle. Okay, some properties of the rectangle is that the diagonals of a rectangle are congruent in measure, congruent to each other, and they bisect each other. So you can see the distance from this corner to here will be equal to the distance from this corner to there, as well as this point right here is a midpoint of both of the diagonals. Special properties of a rectangle. Let's continue. We've talked about this before, but a square is a combination of both a rhombus and a rectangle. Therefore, the square is not called an equilateral and equiangular parallelogram because that takes too long to say. It's called a regular parallelogram. Regular. Okay, those two properties combine, and we use the word regular. All right, let's continue with some examples. Since a square is a parallelogram, a rhombus, and a rectangle, all of the properties for the three shapes are also true for the square. The diagonals of a square are congruent. They're perpendicular. They bisect each other. And they bisect the angles. Now, each of these properties come from the rhombus and the rectangle, and therefore the square is a combination of both. All right, let's continue with some examples on the next slide. I suppose I got ahead of myself there. Here is a flowchart of all the properties of the parallelogram, which flow into the properties of the rhombus and rectangle. We add properties of rhombuses and rectangles, and therefore we formulate the properties of a square, which houses all of those above it plus more. All right, let's look at some examples on the next slide. I promise, examples coming. All right, example 1. Let's first name this parallelogram. You can see it's both equiangular and equilateral. That tells us that we are working with a square. Now, what do we know in a square? We know that all four sides are the same. Therefore, if all four sides are the same, then my perimeter is equal to 4 times the length of a single side. Okay, so I have 4 3x plus 5s. Now you could add 3x plus 5 4 times, or you could just multiply it by 4. Okay, so the perimeter would be 80, which tells me if the perimeter is 80, then a single side, if I divided both sides by 4, then a single side, which could be represented by 3x plus 5, would equal 20. Now I could solve for x by subtracting 5 and dividing by 3. So it looks like x equals 5 centimeters. All right, let's continue with the next example. Now the next example, I've got an equilateral, but not equiangular parallelogram. So an equilateral parallelogram we would call just a rhombus. It's tempting to call that a square because it looks like it, right? It looks just like the previous problem. However, we are not able to confirm that we have 4 90-degree angles. However, we do know that each of the sides has the same length. So I could set 9x minus 8 equal to 73. Solving for x, I get 9x is equal to 81. Therefore, x is equal to 9. So if x is equal to 9 centimeters, and I have a rhombus, then I know the perimeter will also be 4 times whatever a single side length might be. In this case, the side will be 73, and thus the perimeter would be 292 meters. And I marked centimeters up here. That should be meters. So perimeter, 292 meters. All right, let's continue with the next example. Okay, so now I've got a square next to a rectangle. The square has a perimeter of 24. Now if I look at the square and each side is worth 2 x's, then the perimeter would be 8 x's. So if the perimeter is 24 centimeters equal to 8 x's, and I divide by 8, I get 3 is equal to x. So x is equal to 3 centimeters. Now in the last part of this question, it asks for the perimeter of the rectangle. Now I'm going to make the assumption that it's asking for the perimeter of the large rectangle. All right, so let's diagnose what's going on here. Pick this apart a little bit. Okay, so if I looked at this rectangle, in a more general sense, I would have 2x and 2x, and I would have a 2x plus 6, and again a 2x plus 6. Now let's count up our x's. I got 2, I got 4, I got 6, I got 8, I got 10, I got 12. So I got 12 x's. My perimeter is 12 x's plus 6, which is also 12. So my perimeter is 12x plus 12. If I know that x is equal to 3, then my perimeter of this larger rectangle would be 36 plus 12, which would be 48 centimeters. Many different ways to go about these problems. That's just one of the many. Okay, let's use the properties of a rhombus in the last example here. In a rhombus, I know that all sides are equal. Therefore, I could say that 43 is equal to 3x minus 2. I'm going to add 2 and divide by 3. So it looks like x equals 15 centimeters. Rhombus swag. Wow. Who made this example? Probably Todd Hill. Okay, 4x minus 5. If we plug in this will be GW, right? This is the length from G to W, or the distance there. I'm going to plug in a 15 for x. That'll be the distance from G to W. 15 times 4 is 60. 60 minus 5 is 55 centimeters. All right, guys, that's it for Chapter 4. Hope it went well. Let me know if you got any questions. See you in the next video.